Parker Motion Manager's Servo Tuner screen allows you to select the different axes to tune. I'm using axis 1, which is my y-axis. We have the default gains set within Parker Motion Manager. You have the basic, proportional, and derivative gains. Then there's the integral gains to help at steady state. There's the integral gain and the integral limit. There's a delay, which allows you to wait some period of time after the move is stopped before the integral actually turns on. Then there's the advanced feed-forward gains. The torque limit is a voltage limit out of the output of the controller. The controller outputs a plus 10 to minus 10 volt signal to the analog servo drive. The servo drive would be in torque mode. If you want to limit it to 50%, you could set this to 5 and it would limit the maximum voltage output of the controller to 5 volts instead of the full range of 10. You have different buttons here to either send it to the controller, though if you just come in here and type a value, you'll notice that it changes blue in color. If you press enter, then it will actually get sent to the controller. So if you type a value and you mouse off of it, it won't actually change until you come back and press enter. Then it'll change black in color, indicating it actually has been sent to the controller. So you can type different values here and then mouse click to send all of them at the same time at the controller, or you can change them individually just by pressing enter. You can save those gains to the project. Some customers don't want to do that. They want to tune each machine individually. You could have 5 different machines all with the same mechanics and all start with the same tuning gains. So it's up to you whether or not you want to save it to the project or not. And then you can get from the project as well too. I haven't done that, so it would then reset everything back to the default. You can save to the controller, which issues an e-save. That way when you cycle power, the tuning gains will be retained. You can also get from the controller, so if you first time loading a project, uploading, you can also get the tuning gains from the controller themselves. By default, the sampling is PC sampling. You can also change this to onboard sampling. When you change it to onboard sampling, it gives you the ability to repeat run, which will just run a move constantly. You can erase the graph with this button here. The 0 is for the offset of the channels. The time base is increments your time base, your horizontal axis. You have 4 channels. They're all turned on by default. We've already set some of the basic gains, basic parameters to graph, which are most important: following error or tracking error, the commanded velocity, the actual velocity of the axis, and then the secondary set point, which is all the distances, all the positions, all added together. That's the commanded move and not the actual. And you can also export the data. Let's first take a look at the move settings. So by default, you have a trapezoidal move with a 25% S-curve. You can change it to a triangular move, or you can input your own move that you want to do. I'm going to do first a trapezoidal move. Let's just use the default. The return move will, after it moves out 1 inch, it can move back 1 inch. If you want to move it in the negative direction first, this can be a negative value. So you could move negative and then move back to your starting position. So that's fine. And you give it the distance and the time. What actually gets sent to the controller is the velocity and the acceleration and the jerk settings, and then it'll dwell. You can have an optional dwell before it does the return move. So let's go ahead and enable the drive, and then I'm going to do a single run. I have a P-series motor, which is a 19-bit resolution. That's 524,288 counts per revolution, connected to an ETH actuator, so there is some friction in the system. If I were to do a repeat run, it will just constantly run and then grab the data and load that. All the data is stored in arrays in program 14. And we have different channels. We can turn these on and off. That's our jog velocity, the commanded. And we can turn the channels on and off as needed. The auto scale is turned on automatically, which saves you some time of trying to figure out what your vertical scaling should be to get the axes. So it takes the full range of the channel to set the vertical scaling on there. And then if you use your mouse, the following error, even though you were programming in inches, this shows the actual encoder counts for the following error. So even though this is 51,000, my motor is a P-series with 19-bit resolution. That's 524,000, so that's about 10%, but that's while in motion. When I hit the final position, my following error is around 24,000, so I may want to come in here, increase the integral gain. The proportional gain would also help pull this into effect. I would want to increase these tuning gains slowly, and then after each cycle it'll rerun the move and then update the graph. So eventually I could get to a much better value. And because the auto scale turns on every time it cycles, it may end up changing your vertical scaling. You can see now I'm at 7,000 counts per vertical division. And so it is getting better. So it's an iterative process to get the tuning gains dialed in based on your mechanics. This will be based on the friction in your system, whatever is connected to the motor shaft. Now you can see we're around 14,000 counts, which sounds bad except for it's over 19-bit resolution, so that's about 2.6% that we're within the final target position. We could continue to increase the integral gain if we needed to. If I wanted to further look at the actual data, I can display the data, which shows me all 4 channels. The other thing that we can do is we can export the data. So we could save it as a Unicode or a tab delimited CSV or a text file. That way I can import it into Excel and look at the data other ways as well too. Okay. So that covers the Servo Tuner screen. Thanks. Bye-bye. New addition in Parker Motion Manager 2.2. On the top right hand corner of the scopes and the Servo Tuner, you'll notice that there's you can now select user units. Previously, your positions will be all based on raw counts, so the secondary set point P12295 I've got for axis 0. I happen to be in revolutions for my 19-bit resolution P-series motor, which is 524/288. Now I have to convert that, divide that by that value to put it in revolutions. Now I can just select user units, and boom, one rev. So that'll affect anything in terms of the position parameters. So following your actual anything you select here will be scaled based on the axis pulses per unit, which is the scaling calculated based on the configuration wizard. Second new thing to version 2.2, you can now scope a flag. So previously it was always parameters, but now you can select primary axis flags, or any of the flag parameters. You come in here, select flag parameters. I'm going to come in here and then select my primary axis flags. You can select the master flags if you're doing a coordinated move, interpolated move. The Servo Tuner does a single axis jog move. So let's say I want to see exactly when the jog active bit turns on and off. So I can come in here, select this bit. I can select multiple bits as well too. And then if I do a single run with this turned on, I can see let's go ahead and turn the secondary set point off. So you can see I start to move, my velocity is starting to accelerate, my jog active bit turns on, and then I stop and my jog active bit immediately turns off. And then I start to move in the negative direction, it turns back on, and then I stop and it turns back off. So this is nice because with the oscilloscope we can use the onboard capture for seeing exactly when flags turn on and off. So that'll be a nice addition with 2.2. That'll be released in May or June 2021. Thanks.